ChatGerry, stroke risk estimation using both the Framingham Stroke Risk Profile and the VMT energy model over 16 years of longitudinal data. Number 1376, VMT Sharp 717, October 3, 2025. Gerald C. EclaireMD Foundation. Category: Neuroscience and Stroke. Mission statement: I write these medical papers not for fame or recognition, since I have already lived a long and successful life, though not always a healthy one. My purpose now is to share what I have learned about health, disease, and medicine, so that others can better understand their own conditions, prevent illness, and live longer, healthier lives. Introduction. Stroke is one of the leading causes of death and disability worldwide. The Framingham Stroke Risk Profile, FSRP, provides a widely used statistical estimate of stroke risk, but it is heavily dominated by age. This makes it helpful for populations, but less sensitive to lifestyle changes in individuals. By contrast, my VMT, viscoplastic medicine theory, energy model integrates nonlinear dynamics and cumulative damage to provide a more personalized measure. Here, I compare the two models side by side, using my 16 years of longitudinal data. Results: the Framingham Light Stroke Index starts very high at 139 in 2010, declines sharply through 2012, then stabilizes between 90 and 95 through 2025. Its shape is smooth, steady, and largely unaffected by lifestyle fluctuations. The VMT Stroke Index begins at 158 in 2010, drops to 102 by 2012, then stabilizes around from 90 to 92 after 2015. Unlike Framingham, it reflects dynamic ups and downs that match changes in blood pressure and diabetes control. The two curves are highly correlated, 99.5% correlation. Their absolute levels differ by only about 2%, except in the early years, when diabetes was the dominant driver. This close alignment means that, even if I used Framingham values directly as VMT strain inputs, the overall pattern would remain very similar, with only minor differences in scale. Pathophysiology and interpretation. Stroke risk is driven by both large vessel and small vessel injury. My case illustrates the small vessel pathway: decades of diabetes, weakened and calcified cerebral microvessels, while an acute blood pressure surge of 175 mm of mercury in June 2025 triggered rupture near the pons. VMT contribution ratios confirm this mechanism. Real age, 26%, SBP, 34%, T2D, via EEG, 40%. This supports my interpretation that diabetes is the corruptor over time, while hypertension is the trigger for my acute events. Framingham remains valuable for clinicians, but its age dominance fails to capture personal improvement. The VMT model, on the other hand, shows how lifestyle change stabilized my risk after 2010, despite aging. Conclusion: Framingham offers statistical familiarity for populations. VMT provides mechanistic clarity for individuals. Together, they suggest a future of stroke prevention that blends broad clinical tools with personalized, physics-based modeling. Disclaimer: this content is provided for educational reference only, and does not constitute medical advice. No doctor-patient relationship is created. You may share this summary freely, but it must not be altered, edited, or republished as your own. All intellectual property rights and copyrights for this article and its related materials belong to the author, Gerald C.